first two are the types of problems
solving problem.
designed to solve the problem. And then the last one was the types of variables and how they work. Yes.
All right, so it was asked what's some examples of functional languages. Scheme is a functional language. Lisp. Prolog is a functional language.
Oh,
The TI graphing calculator. TI graphing language is a functional language. So like an example would be like in Scheme, you might have functional languages tend to operate on lists. So you might have a function called car that operates on the list 1, 2, 3. So the result of this would be 1. Car says, get me the first element of a list. Doesn't matter what car does. It just matters that we have a function, this guy right here, car. This is the function. Okay. And this is what it applies to. Okay. This guy. Now you asked, is it like methods? So that's what you asked? Okay. That's what you said, right? Methods? We're going to talk about methods here as it relates to Java. We're going to write functions or methods in Java, but languages that are functional languages are built around functions, not that they let you make functions. Okay, so our languages we're going to look at in here, high-level languages, they allow us to create functions, but functional languages are a collection of existing functions that you put together. I mean, it doesn't necessarily change the way that the programming language works as much as it is how they look. So that's why I kind of leave functional languages out to the side. Functional languages tend to be, well, actually, I'm really glad you asked this question because it just reminded me of our next list of, there's two types of, I did forget one. Functional languages tend to be loosely typed. They tend to be high level. They tend to be interpreted, which we'll talk about here in a second. Programming languages. So they are, they tend to not be focused on performance. They tend to not be focused on they tend to be focused on elegance and problem solving, not on speed. I guess would be the punchline. If I can show you an example here, let's see if I have. So I'm teaching a programming language theory class right now, CSC535, and I think I can open a recent thing here. Okay, so for example, this is Scheme. So this is a Scheme programming language. So that code that you see right there, if we were to write the equivalent code in a language like Java, it would probably be 2,000 or 3,000 lines of code. This is solving a very complex problem. But functional languages allow us to express complexity elegantly if you forget about performance. I guess kind of that's like the high level answer that I can give you without getting too deep into it.
Okay, that kind of thing like when you're writing a web page, we always have a plain text JavaScript package and a simplified package of JavaScript. Is that like this kind of thing?
No.
Because I can see it's in a very long line.
Yeah, but that's just more the nature of what JavaScript is trying to accomplish. JavaScript is going to be a loosely typed, high-level procedural programming language. That's what JavaScript would end up being. And you're saying that every single page that you have includes this .js file that has a whole bunch of built-in functions, things that you've created already that you find handy on every web page. Those aren't, it's not a functional language. Those aren't, you may have created a whole bunch of functions that you use, but that's not a functional language. So, the problem is I really should just stop covering functional languages because they're very difficult to explain and they're so rarely used.
Because I never heard of it, so I'm asking.
Yeah. That's a better way of explaining a functional language.
I use Prolog before for gaming.
For gaming?
Yeah, like puzzles, puzzles.
Oh, right. You wrote an AI.
Yeah.
Yeah. Prolog's an artificial intelligence language. Yeah. So is Lisp. Scheme is a superset of Lisp. So what you were just looking at in that screen was Scheme. Functional languages are all about taking functions that have already been created and using them together to solve problems. Procedural and object-oriented languages are languages that have some built-in functions but give you tools for creating your own functions that you then use to solve problems. Now, that isn't to say that you can't create your own functions in functional languages, but functional languages tend to be pretty full-featured to begin with so that you can just start solving problems in terms of the functions that are provided to you. So really think about it like a graphing calculator where your graphing calculator has a whole bunch of functions built into it for doing math. And you don't really need to invent new functions in order to do math. You can calculate the sign of something. You can calculate the derivative or the integral or things like that. Those functions are built in, and now you just have to apply those functions to the problems. I guess that's really what a functional language is. I mean, there's a gray line in there. So I don't think it's a real clean way to answer the question. Nobody would ever sit down and write, I would say less than 1% of all programs are written using a functional language. But like 95% of all artificial intelligence simulations are written using a functional language. So it's very domain specific in terms of where you're going to use the language. I don't know. I'm going to give myself like a C- on that explanation.
Okay, I want to make about something about the procedure. When I say set of functions.
For what, procedural?
Yes, I can set of functions. Like, because when I go to write C and create function, I can call this function because I'm going to give many prototypes. And
Yeah, but you can do the same thing in an object-oriented language. They're just called methods.
okay, what about
So in
that?
C, they're functions and procedures. In Java, they're all called methods.
Okay. Or what about the libraries? Some libraries come with that, with that language. I can call these functions.
Well, yeah, I mean, a library is a collection of functions. Just like, his web pages he was referencing include a JavaScript library, which is a file that has a whole bunch of pre-written stuff that they use often in JavaScript so that you have access to that crap on every single page. It's probably form validation stuff, things like that for, that you use on every single web page. That's like including a library in a C++ file, a program or something like that.
That's mean can I say function is a small changes and procedure is bigger and object-oriented is bigger than or not?
No, I don't think so. Because I don't think that really captures the difference because all of these have things that are functions in them. The difference between procedural and object-oriented in terms of functions is just what we call them. Procedural languages tend to have functions and procedures. That they're the same exact thing. One returns a value, one doesn't. Object-oriented languages just calls all of those things methods, but they're all the same thing. So I don't think you can talk about the difference between these in terms of the size.
Because I think the computers come from the terminal or the functional.
Oh, it definitely is. It definitely is. So, I guess the short punchline would be that don't worry about functional. It is a confusing topic. And, I've been teaching programming for 15 years, and if that's the best I can do to explain it, it's just confusing. It's pretty easy to differentiate between procedural and object-oriented. We use that telephone example. That's pretty clear. That's an A+ analogy in that one, right? C minus, A plus. It's like a B plus. B plus, A minus. Round up. Good attendance. So yeah, functional languages are just difficult to really say what they are, because you can't put it into that. You can't pigeonhole it like the procedural and object oriented. It's a whole different animal. Kind of like people who try to compare baseball and cricket. Man, I tell you what, cricket should be it's like a made up sport.
It is.
I know. I mean,
Don't jump.
Actually, I was surprised. Only one person here plays cricket.
You said 1.5.
1.5.
Yeah.
Who's a cricket fan in here?
I went to the Lord's cricket field out in London, but yeah, I fell asleep during that description.
I mean, so I had a class. I think it was a couple years ago. Was it 2 years ago that Sri Lanka won the world championship or lost in the world championship? India against India.
Against Sri Lanka.
Okay, who won? Okay, so was that last year or 2 years ago?
2 years ago.
2 years. Okay, so my students convinced me to go watch this game. You know, because they were trying in class, they were trying to explain to me how this dumb sport works. Okay, so I come back. I mean, you know, I come back thinking that I watched. I have something to talk about now. I remember watching the end of this game or match. I'm not sure what it was the end of. But one team was cheering. And the other team was not. Logic would say that the team that was cheering won. Totally not. They didn't win. They lost. That was the team that lost. I didn't even. For all I know, it wasn't even the end of the game.
Nice.
I mean, it might be like the first quarter, or I don't even know. I mean, it just seems so weird. I mean, the problem is, I think this is the real problem. I think cricket is actually a fairly complex game. And Americans can only handle things as complex as baseball. Anything more than that is like, okay, you got to dumb this down for us. You know what I'm saying? I think there's truth to that. So I consider myself a pretty smart guy. And I mean, I've looked up online to try to tell me about cricket. I've watched it. I can't even tell who wins. So clearly, it's a dumb sport. It can't be me. That's the point.
For me.
What's up?
Baseball's the same things for me.
Baseball or basketball?
No, baseball.
Yeah, I can't stand baseball.
Yeah, me either.
When I was a kid, I played baseball, so it's like cool when you're a kid.
Mm-hmm.
But I mean, give me a break. I have to sit there for 9 innings watching, you know, these people like scratch their crotch and spit. They should make it 1 inning, sudden death. All sports should be that way. Same thing. I mean, I'm a big NBA fan for basketball.
Mm-hmm.
So I guess I'm a Milwaukee Bucks fan because I like watching Milwaukee Bucks basketball, but I'm a Miami Heat fan when it comes to who I want to win the championship. I like watching good basketball. You're not going to get that out of the Bucks. Because I'm a realist at the same time. I'm under no illusion that, you know, a great season for the Bucks is they make the playoffs. Magical season, they go 1 round. We don't have the genetics to compete with some of these other teams, and I'm cool with that. So you go out to a game, doesn't matter if they win or lose. All they're playing for is an extra 4 games at the end of the season. Because chances are they're going to, just like last season, we made the playoffs, and who we run into in the first round? Played Miami in the first round.
And get blown out.
We do not have the genetics to compete against the Miami Heat in basketball. I don't care how good the Bucks were that year. We were lucky that the series lasted 4 games in a best-of-7 game series. Yeah, do the math. It was bad. Yeah, but even NBA, they don't really start trying until the 4th quarter. You know, so you get to the 4th quarter, the game's either close, and then they all start trying, or it's a blowout, and now it's about not getting people injured. Sports is dumb. Same with football.
I love
mean, I watch football every week, but wouldn't it be more exciting if if the kickoff meant something and it was sudden death? First team to score wins. That's how boxing works. Yeah, it's 12 rounds. But if some dude gets knocked out in the first, it's over.
But like it's a different case in cricket. Last player can also like make you win.
The-
Last player. And
Yeah,
last
but like,
player
don't
can
some cricket matches like last like multiple days?
5 days.
Yeah.
5 days.
That's pointless.
It's like if you like follow that, it's pretty interesting. And it's a kind of gentleman game. It is considered as
Like golf.
Nah, that's like curling. It's not really a sport.
It's like curling.
It's a made-up sport.
No, I agree. Curling is not really a sport. I think cricket is more of a sport than curling. Cricket, I think, it requires athleticism. Curling does not.
That's true.
Curling is a strategy.
Curling
You're gonna
is
say?
stupid.
No, there are 3 types of matches in cricket, like 1 day and 5 days, and one is 20-20. So it's depends like how long you can watch.
Yeah.
Yeah, 1 day is like 50-hour match. It will be for like
7 hours.
A 7-hour match is a 1 day. That's the short one.
Uh, no, short one is like 20-20. It is spread for
4
3
hours.
hours. 3 hours. 3 or 4 hours.
3 or 4 hours. That's the short one. So that's soccer. Okay, so that's like soccer.
Yeah, the match. Yeah, I think you have watched India versus Sri Lanka is for like 1 day.
It was like 50-hour match. So it was the
50-hour match.
7 hours.
Ain't no way.
50 over, like in over, you have 6 balls. I think
6 deliveries. You need to face that.
So 50 multiplied by 6. So
300.
one team should ball 6 like 50 overs, 300 balls.
Do they go to sleep?
Like in 300 balls, like it depends how much runs the other team makes. And after that, the other team plays like 300 balls, so we have to like chase the score. Whatever the
Why so long?
is
Like when they were coming up with like the format for this, why didn't somebody just say, okay, look, we don't need to go for a month in order to decide who wins this game?
No, like they have all 11 players in one team, so like it's like everyone should get a chance to play.
Oh no.
I get it.
If you have like 10, 20 balls, like only 1 or
Yeah.
2 players will play, then what the other players will do? So like everyone should get a chance.
That's how the NBA works. Your name's LeBron James or Dwayne Wade, you play. Everybody else is just standing out there and pretending like the ball might come to them.
Mhm.
It's just dumb. All right. So, let me give you another slide here.
Your expressions are priceless.
Mine?
Yes.
I know, it's so good. 2 types of programming languages. We have interpreted and we have compiled. Okay, so for you, this slide deals with the difference between languages from the perspective of how the programs written in these languages are executed. Interpreted languages are executed in real time at runtime.
How the program executed.
Yeah, it's from the perspective of how the program written in these languages is executed.
Talking to Siri during class. What's going on here?
Okay, a compiled language is executed based on previously interpreted code prior to runtime. And we'll talk about these individually. Executed based on previously interpreted code prior to runtime. So, to kind of put this in perspective, we're talking to a computer. But let's take this to human languages first. Okay, so you're from Saudi Arabia. So what's the native language?
Arabic.
Arabic.
Saudi Arabia.
Okay, I don't speak that. Saudi Arabic?
Saudi Arabia.
Saudi Arabia.
Yeah.
And the language is Arabic.
Arabic, yeah.
Okay, there's not like multiple versions of Arabic.
I can
Maybe
do it.
slangs or
Yeah, because like isn't it India? I think isn't there like a different like different
slang or
like within like walking distance of different cities.
126 languages.
It's like
In India? That's doing too much.
126 languages. Is that what you said? Yeah.
650.
Whatever it is, it's just like cricket. It's confusing. Okay, so back to the example. So point is, natively you speak Arabic.
Yeah.
I don't. Okay, so let's say that you did not speak English, and I need to be able to communicate with you. So I speak English, you speak Arabic. We can't talk to each other directly, right? Huh? I need an interpreter. Anybody else in here speak Arabic? All right, we got this. Who speaks better Arabic?
I don't know.
All right. I'm gonna go with him because I don't trust this guy. Okay, so anyway, so he's gonna. But you also speak English. You one up on this guy because he slacked in school. Because doesn't everybody have to take English in school now?
what's the question again?
Doesn't doesn't everybody have to take English in school now, regardless of kind of what country you're from? Didn't you, when you were in school, you took English, didn't you?
Yeah.
Yeah, because the Americans aren't going to convert.
No.
Yeah. Everything's about the lazy Americans. Say, we're not converting. So you want to come talk to us? You learn our stupid language. All right, so anyway, so he speaks English and Arabic. I speak just English, you speak just Arabic. So in order for me to talk to you, I need to talk to him, and in real time, he's going to interpret what I'm saying and convert it into Arabic for you. Okay? That's an interpreted language.
Hold on, wait. So, in order for you to talk to Bender, you say it to Uthman. He interprets it and translates it back to Arabic.
I say English to him.
Yes.
English goes into his head. Goes in one ear is English. Comes out of his mouth as Arabic to his ear.
Gotcha.
He responds. Goes in the other ear as Arabic. Comes out of his mouth as English back to me.
So he's just your translator.
He's my translator.
Gotcha.
He's my interpreter.
At the same time.
Okay. So am I going to be able to communicate with you then? With an interpreter, I can then communicate with you, right? But it's slow.
Sure.
Right? Because of this middleman.
Mm-hmm.
Okay? So interpreted languages work that way. It's happening in real time. I am speaking English at the same time as you are understanding Arabic. So I'm speaking Scheme or PHP or something like that, some programming language, at the same time as the computer understands zeros and ones. Okay? But at the exact same time, at runtime, while the program is actually running, we have an interpreter. We have a dude like him who's listening to whatever language I'm spitting out and converting it in real time to the language the computer understands. Okay? Nothing wrong with it, but certainly doesn't scream high performance. Make sense? A compiled language will work this way. Let's say I have a long thought that I want to convey to you. So rather than it being this back and forth conversation thing, I'm going to sit down and I'm going to dictate to him. I'm going to say, this is what I'd like you to say to him in Arabic. And I dictate the whole thing. He writes it all down. So he listens to my English, writes all the Arabic down. So he can hand you a piece of paper and you can just read it. So maybe I said just as much as I said to you in this real-time conversation. But in this case, he's pre-writing it. He's pre-interpreting it. So when you get the message has already been interpreted into Arabic and you're just going to read it natively.
So the interpreted one is faster than.
Other way around. The interpreted one is when I'm using an interpreter. The compiled one is when I get all my thoughts out there, give it to the interpreter, who then converts it way before he has to talk to you. So maybe he converted it a week ago for me. Kind of like, you get a book, and a book gets translated into another language. It's not like that's translating in real time. Somebody got the Bible and converted translated the Bible into 30 different languages, and then you go and buy it, and now that's the, that's the deal. Okay, so that's how a compiled language would work. The work was done up front so that it's real time while it's being executed. Okay? So interpreted should scream slow. Compiled should scream fast. In an interpreted situation, you are receiving my message slowly because it has to go through him in real time. In a compiled language, you are receiving my message quickly because it went through him a while ago. His time was not your time. Okay? You're just benefiting from it. So now to kind of tie the knots here, compiling. We have this term called compiling. How many of you have heard of compiling before? How many of you have actually compiled before? Not only have you heard of compiling, you've actually compiled. Who could tell me what compiling is?
Compiling, like you're taking an application with a tool, you're recompiling to a latest Java version through a compiler. For example,
Okay, so hold on. I want an opportunity to make fun of you. Okay, so I asked you to tell me what compiling is. I heard you use the word compiling a minimum of 3 times in your answer. Have you thought about going into law? Type of thing a lawyer would do, right? Start talking in circles.
for example, if you have an application, right, which is compiled to 1.4 Java.
What's compiled?
You can pretty
Then,
much use
if you want to have the same application need to be installed on a 1.6 Java, then you use some sort of a recompiler, compiler.
Okay, but you said it was compiled in 1.4. What does it mean for it to be compiled in 1.4?
You're making that the same application to be compatible with the latest level of Java.
Okay.
It's the latest 1.6.
Suppose we have different material and we are gathering the whole material and making it one book. So we are gathering the whole information, putting it together and putting it in one book. So we are compiling it in one book.
All right, let's say no.
All right.
You can take a stab at this?
Yeah, you're when you're writing code and you need to compile it, it's pretty much taking that code that you've just written and then it's making sure that everything you have in that code can be translated into the machine language so that it can run or you can debug it.
In simple word, compiling is converting from one format to another format.
Okay. I like what you said, and I like what you said. So let's put those two together. Specifically, what format does it go from?
Go
We
from
write the
program
program
language to machine.
Human understandable language.
So you said what to machine?
It goes from programming language to machine language.
Okay.
Whether high or low.
I'll tighten that up a little bit. I'm going to say that compiling goes from a high-level language to a low-level language, not to machine language. Okay? And the evidence is what we talked about earlier. So compiling, translates
Because it goes down a level each
from
time.
high level to low level. And remember, high level had a one-to-many relationship with the CPU. Low level had a one-to-one relationship with the CPU. And when you execute a low-level language, it gets mapped to magic tricks on the CPU. So there's two levels of translation. So for those, if you've been in the industry, you've probably heard two different terms before: compile
Compress.
and linking.
Oh.
Ever heard the linking before? Compiling and linking. Ultimately, what you produce is a set of assembly language instructions, a set of low-level language instructions that we can feed to the CPU, and the CPU interprets them based on its list of mapped functions, mapped magic tricks, as I refer to them.
Can you repeat that, please?
Which part?
That last blurb of
Probably not.
the linking.
Compiling and linking is kind of a two-step process, because often you have a program, like you mentioned with your web program, that has JavaScript, a JavaScript library you bring in. You're going to compile a high-level program language down to a low-level language, but at the same time, you need to link in any extra libraries. So what you're left with is a pile of low-level language, collection of low-level language. That is the type of food that a processor eats. Okay? Processors eat instructions from a low-level language and react to those instructions by performing the magic trick that each of those maps to. Does that make sense? So in that respect, a CPU is kind of like a pet. That's the kind of food you have to compile to feed your pet.
So when it's when you're debugging a program, that's when it's doing the linking or making the low level go down to the machine level.
You're debugging. Depends what you mean by debugging.
Like trying to run the program. Put it like that.
Okay, when you hit the play button.
Yes.
Yeah. Everything's in VCR terms now, right?
Yes.
Yes. If you are in a tool like Visual Basic or which would be Visual Studio, or you're in Eclipse, we'll use Eclipse in here. When you hit the play button, the magic that happens behind the scenes is your program is compiled, linked, and executed. And the execution step is when the CPU feeds off of assembly code, feeds off of low-level code, and performs magic tricks as a result. Make sense? Okay. So the thing that we should really think about at this level, notice that the pattern that's emerging here over the last couple of things we've talked about deals with performance. Interpreted languages tend to be lower performance. Compiled languages tend to be higher performance. You know, I can only speak to him so quickly if you're interpreting what I'm saying in real time. You've got to be able to keep up, right? It's not that we can't pull it off. It's that I can only babble so quickly. You're cheating? You're cheating on notes?
I don't want to bother you.
You can use the
Which
compiler
one?
just
This is
one time.
Say this again?
You can use him just one
This one's
time
the lower level.
as a compile, not like interpreter.
Well, the compiled version of that is, let's say all three of us aren't in the same room. Compiled version is I write my email in English. I email it to him. He reads my email and says, okay, well, let me create the Arabic equivalent. Then you send that completely converted email to him, and he just reads it in Arabic. That's the compiled version. So it's not a real-time thing. You know, you converted my words completely separate to him experiencing my words. So you might have done it on Tuesday, and 6 months later, he actually executes my words by reading them. But he's reading them in the language that he understands, not in the language I originally delivered it in. I delivered it in Java. He's reading it in assembly language, if he's a computer. Does that make sense? And quite frankly, if I was trying to speak to you in Arabic, I might as well be using assembly language. I know assembly language much better than Arabic.
Which have the
Assembly language?
no the Arabic.
Yeah. All those languages seem hard to me. I have a student, undergraduate student, who I believe he's writing. I'm just gonna say, I think Arabic. He writes this little saying at the top of every one of his papers, and he's told me what it
From
means.
the
or
right
something.
to left or the
Oh, I don't know. It just looks a bunch of squiggles to me. I'm just saying. But, you know.
yeah, this is the fact, not opinion.
Yeah, I mean, I can't even imagine somebody be able to read that.
Yeah, it goes right to left. That's interesting, though.
Oh, I'm sure it is. And I'm sure, it's not nearly as complex as I'm making it out to be. It's ignorance. I don't know the language. You know, I mean, you speak it, right?
Arabic.
Yeah. Yeah. So I mean, you don't seem all that bright. He got confused there for a second. Wait a minute. I'm just saying, if you learned Arabic, it seems like I should be capable of learning Arabic.
He was born learning Arabic. That's what he was surrounded by.
I was born here and I don't speak English. This is some bastardized version of English that Americans spit out here. Want to speak the Queen's English, you got to go to London, right?
That's true.
That's where they know English.
Uh-huh.
Okay.
Like the rubbish.
The rubbish. All right. So, didn't I create a slide here for Java? Okay.
Yes.
Let's talk about Java.
Just I have a question.
What?
Okay, just ask a question. Okay.
Go ahead.
Okay, about what you said about the compiler and the interpreter for that. Can I link for this type of programming for the purpose slides when you said about the loosely typed and slowly typed?
Kind of their links. Okay. Yeah, I can do that. So let's okay. Most languages we'll deal with will be high-level languages. Okay. Low-level languages don't fit into categories of loosely typed or strongly typed or anything like that. Low-level languages exist to be eaten by CPUs. Okay? That's the only reason low-level languages even exist, is so the CPU can eat them. Because they have that one-to-one relationship. All right? Now, functional languages tend to always be interpreted. Procedural languages often are compiled but may be interpreted. Object-oriented languages often are compiled but may be interpreted. A good example of it's almost a hybrid between a procedural and an object-oriented language. A good example of a modern-day high-level procedural / object-oriented language that is interpreted is PHP. Okay, PHP is an interpreted language. JavaScript, also an interpreted language. Who interprets JavaScript? There's a piece of software, an interpreter that lives inside your web browser. That's who interprets it. So when you get total geekdom and you like programming, you're at somebody's house and you need to solve a problem and the correct tool for solving it is writing a program to solve it, yet you don't have any computer stuff laying around, as long as they have a web browser, you can write a program. Open up Notepad, write it in JavaScript, run it in the web browser, you got your answer. See, that's the MacGyver way of writing software. Do they have MacGyver in Saudi Arabia?
Or no one. Okay.
I taught you about this in the previous class.
You're so special.
No, you give us another word.
Oh, I definitely didn't get another word. I don't know that many words.
Forget the word.
Okay.
All right, so anyways. Now, general purpose languages are almost always high level. In fact, I would say are always high level. Are always procedural or object oriented. Oh, well, no. They can be any of the three. And can be compiled or interpreted. I don't think that makes a real strong case there. interpreted languages are almost always loosely typed. Compiled languages are almost always strongly typed. I think that tends to be a truth. So I guess I connected some dots. All right, so let's talk about Java. How many of you have heard of Java? Okay. Well, first of all, let's describe Java in terms of all that crap we just talked about. Java is a high-level, object-oriented, strongly typed, compiled, general purpose programming language. That's Java. That cover all my slides? Let's see, it's high level,
Did you put compile?
it's object oriented, it's general purpose, it's strongly typed, and it's compiled. Yep, I think we got it. All right, so that describes the Java programming language in terms of our multiple, there are 3 kinds, there are 2 kinds of language crap. Okay, so if you were at a store looking to buy Java as if Java was a product, what are the selling points that you know of for Java? Like, what's good about Java?
No memory leak. For like
No memory leaks, okay.
We need, yeah, for like Internet Explorer, some of the, to run you need the Java compiler. We need the JavaScript to run some of the program. World Wide Web.
Okay, well, right off the bat, JavaScript and Java are not the same thing.
Yeah.
They share a name. They share that word Java, but they're not the same language, not related. So it's huh?
No head file.
Okay. Let's go back to the C++ days, C and C++ days. Let's say you were a video game fanatic on computers. And back then we had this war between Apple and Microsoft, right? Like, do I get a Mac? Or actually back then it was, do I get an Apple computer or do I get a IBM compatible computer? And for gamers, the answer was almost always get a PC, what we call today a PC. Why? Because when companies came out with video games, they wrote a game for a computer, for a PC, it would come out for the PC first. Why?
Because it's more general.
More of them. So if we line 1,000 people up today, and we take a poll, how many of them run Windows versus how many of them run the Mac OS, what do you think the breakdown will be? It'll be closer today than it's ever been in history. What do you think the breakdown would be? Out of 1,000 people, how many of them do you think will be running Windows?
900.
I would say 900. Yep. So, and that's as close as it's ever been. Okay? And realistically, it'll probably be higher than 900. I think we're maybe being nice by saying only 900. You might have a couple of people in there who run both. So you just throw them in the Mac camp. Like, they're at least running Mac, so it's, that's okay. So if you're writing software, writing a video game, you're going to write it for, I mean, you ultimately are doing it to make money, right? So you're going to write it to to sell to the most people. The most people were running Windows on a PC. Now, if you were a Mac user, you could sit back and hope that the game eventually comes out for the Mac. But very, very, very rarely did games actually get ported to the Mac. Didn't have enough. There wasn't enough users to make it worth the money. It's just the way it is. We can take this a step farther, make an additional connection here. How many of you have heard the claim that Apple has no viruses? That if you run a Mac, you don't have any viruses. How many of you have heard that before? Didn't ask you if you believe it. How many of you heard it? Okay, how many of you believe it? You believe it. You believe it. Okay?
So, I'm not sure.
Now, we all know that Windows has viruses, right? Okay, who writes viruses? Programmers, right? Mean programmers. Okay, if you're a mean programmer and you're writing viruses, what's your goal? To piss people off.
Yeah. Mess up something.
Okay? So if your goal is to piss people off, and you got 1,000 people sitting in front of you, are you going to aim for the 100 or are you going to aim for the 900?
900.
You're going to aim for the 900. No wonder there's so many Windows viruses. Now keep in mind, I'm a Mac guy. Okay? So I'm about as biased as you can get. I use Macintosh computers because I run both. And a Mac is 2 computers for the price of 1.7. It's actually a good value when you look at it that way. I can run Windows and the Mac operating system on my machine, where your PC can only run Windows or Linux. You can't run the Mac natively. There's Hackintosh, you can fake it, but that doesn't work out well. So I view it from my profession that I have one computer that can run both for 1.7 times the cost. That's a 30% discount. is what it boils down to, instead of having to carry around 2 laptops. But, I mean, there is no reason why there could not be viruses for the Mac. And there are a few. You could make an argument that the operating system that Macintosh runs today is actually based off of a Unix-based operating system, which is typically considered to be very secure. I think you could make the argument that it would be more difficult to write viruses for the Mac than it would be to write viruses for Windows. But not like drastically. You know, maybe 20% more difficult or something like that. You know, the real reason there aren't that many viruses for the Mac is because there's not that many users on the Mac. I think over the next several years, you're going to start seeing, I mean, iOS for the iPhone is based off of the same code base as the Mac OS, so it's a Unix-based operating system as well. I think you're going to start seeing some people being pretty interested to piss off iPhone users. Maybe you'll start seeing viruses come out there. You already see it on the Android side, which is also a Linux-based platform. You know, the real difference there is how their app stores work. You know, Android, you can put an app up there and 30 seconds later it's live. For iPhone, you put an app up there, they test it for a week before they put it up there.
Now, most of the cell phone users use the iOS. Why there is no viruses for that?
Well, that's kind of what I'm getting at, is there will be. And most, I would say it's not fair to say most cell phone users use iOS. I think it's fair to say most cell phone users use iOS or Android. I mean, I think iOS plus Android equals an increasingly, a number that is getting closer and closer to 100% every day. You know, I think it's fair to say that it's probably 97% of the smartphone market is one of those two. You know, BlackBerry, Windows Mobile 8, very, very, very small market share.
They need to get rid of those Windows phones.
No, they actually play an important role, I think. You know, let's say Microsoft does 50 things wrong, they might do 3 things right that helps the other 2 get a little bit better. You know, and there's nothing wrong with that. You know, that's Microsoft's play. Where does Microsoft make their money today? They make their money with Microsoft Office and they make their money with Xbox.
Sure.
You know, that's their cash cow. Everything else is just for them to stay relevant. I mean, there's nothing wrong. I mean, that's business. It's not like Microsoft's hurting. They have cash. They don't have Apple cash, but they have cash. I mean, nobody has Apple cash anymore. So, well, but there's probably a couple of sultans or something in Saudi Arabia. They might have Apple cash.
Apple Cash?
See, he doesn't know English.
No, I know.
No, actually, I think right now Apple is the most valuable publicly traded company in the world. Their market capitalization is like something like $430 billion or something like that. But I think that to find the most valuable company in the world, I think it's some company in Saudi Arabia. I think.
I mean, the oil company.
Yes, it's an oil company that's government supported,
Yeah.
I think they're supposed to be worth like $1.5 trillion or something, the equivalent.
I'm not sure about the number, but I think.
You know, it's something like that, but it's not publicly traded, so it doesn't count. So it's whatever. Those Saudis, them and their oil. Hey,
We have 6 Saudis here.
do we? I'm outnumbered.
More than 6.
Why you think I apologize for saying that cricket was stupid?
No, cricket is stupid.
No,
It is, but you
not
know.
from Saudi Arabia. Cricket.
Okay.
Cricket for India.
Yeah. Indians love that.
Not India, like it's followed by like most of the world, not like.
No, that's definitely true. No,
Yeah.
I totally agree. It's same with soccer. You know,
Yeah.
Americans are of the opinion that if we don't like the sport, it's stupid.
Right.
That's
Pretty much.
that's how we work. Because soccer didn't even get somewhat popular in the States until 8 years ago, 9 years ago. Now it's relatively popular here, but we've invented what Major League Soccer here, which isn't anywhere near the quality of play that's in was it Champions League? Is that what it's called? Whatever it is, you know, the
Yeah.
real professional soccer is not played here in the United States. It's played, you know, in the European unions and you know, the rest of the world.
Right.
Everywhere but here. Yeah, I don't know, but cricket is. I agree. It's definitely stupid. I'm an equal opportunity offender, is what it comes down to. All right, so Java is a high-level language. So the question I asked is, if you went into the store and you were looking at what the features of Java are, the big thing would be something that Java is what's called platform independent.
That's the word.
A platform independent. So the example I was going down there is like when somebody comes out with a video game for Windows, it takes time to bring it over to the Mac if they even choose to bring it over to the Mac because they have to rewrite part of that game. That was sort of kind of what you were getting at with the whole compiling for 1.4 versus 1.6, kind of blurry. Huh?
Recompilation.
Yeah, I would call this porting. So platform dependent gets rid of, here, let's say, gets rid of porting code. And what does it mean to port code? If somebody were to write a game, more than likely the game was written in like C++. So if somebody wrote a game in C++ for Windows, and then they wanted to release that same game on the Mac, seems like not a big deal. We just have to find a C++ compiler for the Mac. Because remember, what's the job of a compiler? Compiler takes a high-level language and translates it into a low-level language that can then be interpreted by the processor. Well, Macs and PCs, until recently, used two different architectures. For years, Macs used PowerPC chips, which is a reduced instruction set processor, where PCs use Intel-based chips, which is a extended instruction set processor. So the assembly languages were different. Now the assembly languages are the same on both of them. So it seems like moving an application from one to the other should actually be less of a headache now, which is definitely true. But here's the deal. So when you compile a C++ program for one platform, you get assembly language code that gets eaten by the processor in that platform. When you compile it for the other platform, you get assembly language code that gets translated by the processor in that platform. Now, having said that, there's more to it than we've explained. That is, you have an operating system in the middle. Operating system is a piece of software that sits between the human being and the hardware. So when your game makes pretty pictures and stuff like that fly up on the screen, it's not just doing that directly. It's actually talking to your operating system, which talks to a software driver, which talks to your hardware, which makes pretty pictures show up on the screen. So you have to rewrite portions of your game to talk to drivers differently because they have to talk to the operating system differently. So you have to rewrite portions of the game even though you're using the same language because you're speaking to a different operating system. It used to be even worse. It used to be you were speaking to a different operating system, which was then speaking to a different hardware architecture. On top of that, most video games on PCs use DirectX. That's Microsoft's show pretty pictures libraries, okay, making explosions and a zillion polygons on the screen at the same time, where the rest of the world uses OpenGL. So anything Microsoft-based uses DirectX. Everybody else uses OpenGL. Yet, most games come out for Microsoft first. So they're written using DirectX because that's going to get you the best performance on a PC because it's so integrated into their operating system. And Microsoft invented it. Well, probably Microsoft stole it, then got sued by the company that invented it, paid them off, and now Microsoft invented it. Same diff. So, if you're to rewrite a game now for the Mac, you're going to have to not only port it to talk to a different operating system, you also need to port it to display graphics differently. Write everything in OpenGL rather than DirectX. So, I mean, it's a major undertaking. So that's where Java comes in. This was a huge problem back when Java was originally invented. Java was probably invented in 1994, 5? 95, are you sure?
I was only 5 years old.
Did you already look it up? You looked it up?
I think it's 1990.
1990? Definitely not 1990. Definitely not. I want to say it's 1994. All right, we're going to look it up.
Yeah.
I hate all of you.
Yes, I agree because 1994 was the World Cup.
What does the World Cup have to do with Java?
95.
95? Oh. Uh-huh.
Yep. May 19.
Of what?
Oh, never mind. That's when the dude was.
Well, I'm not even the right thing. James got here.
Oh, because he invented Java.
Where's the date?
1995, yes.
Yes, first released in 95,
That's
but
it.
it was
Second
developed in
paragraph,
91.
first sentence.
All right.
Second paragraph.
Got it.
What?
All right, so 95.
Oh, wait, WikiLeaks isn't, Wikipedia isn't even a relevant source.
Oh, that's perfect. That's good.
Oh, okay.
That was close. That was close. Okay, so 1995. Fine.
Sad.
So back then, it was certainly a big problem, this whole idea of writing software for two different platforms. Because it wasn't just for video games. It was also for business applications. So if you needed Microsoft Word, or the equivalent thereof, for the Mac, and you were currently on the PC, it was a big headache. Because there weren't as many applications. That was the Macintosh killer for years. It wasn't that Apple was innately bad. It was the applications weren't there because Windows had a significantly larger market share. And that just kept growing and growing and growing. So Apple had its little niche, which was in the graphic video industry. Just so happened, so Apple has always been kind of had a cult following, right? You had a group of people who just loved everything Apple made regardless of how good or bad it was. Apple, 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 Apple. And it just so happened that the important people in graphics and video industry were into that idea of Apple being awesome. So they pushed the envelope to get software developed for the Mac for those things first. So like Photoshop, a lot of different video editing software, those were born on the Mac, and that's where, So if you go into a design firm, you're going to see a lot of people with Macs, even 10 years ago. You go into any other place, you're going to see PCs running Windows. So in any case, this was a big deal. Because we were in a world at the time where the internet was just coming into its own. 1995, that's right around the time Al Gore invented that thing. Do you even know who Al Gore is?
Al Gore?
Al Gore.
Person or?
No, never mind. He asked a question.
He can't answer a question with a question.
I don't know.
The joke is he was the vice president of the United States who ran for president, and while he was running for president, he had a comment where he said he invented the internet. So now it's referenced often. It's funny. So anyways, that's when he invented the internet. It was like 94, 95, 96, somewhere in that ballpark. Probably more like 94 is when the internet started being used. So, used a lot. It existed before that. But in any case, this idea of downloading programs off the internet was starting to become a reality. So the people at Sun Microsystems decided, you know what? Wouldn't it be cool if you could write a program once, and that program you compile it once, and that program would run on every computer? Sounds like a good plan, right? The problem is solved. So what did they do? Prior to this, this is how stuff worked. I get to draw pictures. I like pictures. We'd have a game. Okay, so the game would come out originally for the PC. Okay, so it was built to run on the PC. Now, if we wanted that game to then work on the Mac, they would need to port that game, rewrite that game a second time for the Mac. Make sense? Time, money, blah, blah, blah. So Sun Microsystems decided, hey, let's do this. You got Mac and PC. Write the game once for both. Looks great on paper, right? This one is better than this one. When you're looking at it from this point of view, correct?
So this one represents Java.
This is Java over here. This side here. That's Java. Here, I'll put a little text. So that's Java. This is the other crap. All right?
Not Visual Basic.
Aw,
True.
whatever.
True. Don't worry, your Microsoft is going to come back here into this story in a little bit. They come back strong, trust me. It's
Thank you.
going to be awesome
Yeah.
and hilarious at the same time. Okay, so this model looks awesome over here, right? So how did they pull it off? Over here on the left, the other crap, they wrote the game once, then they wrote the game a second time. And if they wanted it to work on Linux, they'd write it a third time, so on and so forth. So what did they do to make Java work this way? Instead, now if there was, let's say we had 30 video games, and they wanted all 30 of those video games to work on both Mac and PC using the other crap, they'd have to write those programs 60 times, right? Okay. So instead, the people from Sun Microsystems, they decided rather than porting every one of your applications, we're instead going to create our own little application called the Java Virtual Machine, the JVM. Now the Java Virtual Machine is just like that game. If they wanted it to work on the PC and the Mac, they had to write it twice. They had to write the Java Virtual Machine for the PC. They had to write the Java Virtual Machine for the Mac. Make sense? But after they wrote those for those 2 or 3 different platforms, they were done. So this game was written in Java, and the game was not run by the PC or run by the Mac. The game was written to run on the JVM. So the way Java worked is you'd write your program once, and when you compiled it, it was not compiling it to assembly language code that could be understood by Intel. it was not being compiled to assembly language code that could be understood by PowerPC, by the Mac side, by the Windows side. Instead, it was being compiled down to assembly language code that could be understood by the Java virtual machine. The Java virtual machine is a computer written in software. So this guy here for the PC understands the exact same assembly language as this guy written for the Mac. What they do with that assembly language and then feed it onto the Mac might be different. It should be logically equivalent, but the virtual machine for the Mac and the virtual machine for the PC are two separate applications that are meant to be functionally equivalent, but the way they pull things off might not necessarily be the same. Over here, this guy had to write things in terms of the Mac operating system, in terms of the Mac hardware architecture. Over here, this guy had to write things in terms of the Windows operating system, in terms of the PC architecture. That makes sense? But Java always, always, always compiled its programs to run on a software CPU called the Java Virtual Machine. So you write your program once, you compile it once, it will run on any platform that supports the Java Virtual Machine. Sounds pretty legit, right? Okay. Isn't this perfect? No wonder Microsoft wanted to steal this. Go ahead. You have a question? No, he put his hand up. I think he was.
Yeah, it's all class of Java.
Cricket practice. Go ahead.
Yeah, my question is, yeah, if you're saying like Java is independent, so like all classes of Java will, can run on the both operating system.
Can run on what, Ubuntu?
No, like I mean, yeah, if there's a Windows and Mac, okay.
Mm-hmm.
So if the Java is independent, okay, with the platform,
Yep.
so it can be compiled on any operating system. So like all the classes of Java will compile on the Windows and Mac. So some of the classes may not be compiled on some operating system.
Well, okay, you're asking it really strangely. If you write a Java program, it doesn't matter what classes you use. We haven't talked about classes yet, but you write any Java program with any legal Java code. It does not matter what the platform is, as long as there's a virtual machine for it. As long as the Java virtual machine exists for the platform you intend your program to run on, it will work. And you only have to compile it once. You don't have to recompile it. I can go down there to, I can go right here, write a Java program, compile it. The output will be this thing called a .class file, which is Java bytecode, which is Java assembly code. The assembly code understood by the Java virtual machine. I can then take that one file, not even my source code, just the .class file, and I can go across the hall to what they call the fishbowl here, which is a bunch of Windows machines. And I can run my program in there without compiling it again. It'll just run. Because I compiled it down to a low-level language that the virtual machine knows how to eat. I'm feeding the same pet. I'm feeding a virtual machine here. I'm feeding a virtual machine over there. Internally, those virtual machines maybe are wired a little differently, but functionally they're equivalent and they eat the same food. Does that make sense? Okay, so on paper, this sounds like a cool idea. No wonder Microsoft wanted to steal it. We have a problem. Goes back to our old problem we talked about before. Performance. Performance, performance, performance. Now, Java is great for business applications. Who cares? Our computers are so fast today. Are we going to notice the difference between how fast Microsoft Word is on one machine versus another? No. It's not a performance type application. As long as Word feels snappy to us, we don't care if something takes nanoseconds less than something else. We're not going to feel it. We do care about our video games though, right? If your video game is sluggish, you stop playing it. You just assume your computer can't handle it, right? Where it very well could be that your computer is fine, but the dude who wrote your game wrote it crappily or wrote it in Java. Even worse. So Java should scream slow performance. Again, relatively speaking. So not slow from a human's perspective. Java's fast. If I wrote a program in Java on here and I ran it, it would run instantly. It wouldn't seem like there's any delay. But if you wrote a program that really, really relied on top tier performance, a video game or something like that, Java's not the platform for you. It's just not going to be able to handle it. So Microsoft, first of all, they like the Java language. Java language had two things going for it. Let's talk about that. Advantages of Java. Well, first of all, it had the platform independence. Clearly, we could say, even though it wasn't ideal for all situations, it was definitely cool for many situations. Right? Platform independence is good. Period, it's good. What else did it have going for it? Better than C++. But hold on. What does it mean for something to be better? It's a very relative term, right? C++ was how all of our video games were written, and they were fast. C++ was a compiled language that you had to port on either platform, whatever platform you wanted your game to work on. Super, super, super fast. But C++ had its shortcomings, especially from a teaching perspective. So historically, the first language computer science students would learn is either C or C++. Usually they would learn C first, because you always learn procedural programming before you learn object-oriented programming, even if you're using an object-oriented language. Like when we start in here, we're going to be approaching Java, which is an object-oriented language, from a procedural mindset. So we won't be taking advantage of the object-oriented aspects of it until 3 or 4 classes in. So we might as well be learning C at that point. Okay? But when you finally got into C++ or C, it had the same issues. For a beginning programmer, C, very robust language, very good language, but you could get into trouble quickly. And I'll talk about some of the things here at the high level. We'll talk about them again when we cover the topics from when we start talking about the programming side of things. But just as an example, things that C or C++ let you do that would never make sense. So let's say that you are having a party at your house, and you're inviting your best buddy Mike over. That's my name, by the way. My first name is Mike. You didn't get that. You knew, right?
Yeah.
Because I'm questioning what you do know at this point. Oh yeah.
Slow performance. He's Java.
No, he was like my favorite student last year. You took 250 last fall, right?
Yeah. Thank you.
See? Now he's taking 250 again right here.
Well,
I'm going to take the advanced one also.
537? Is that the next class?
Yeah.
Audience, maybe.
I actually signed up for that one already.
When is that one?
I think it's session A.
What's that mean?
It's starting week
That's
of January 27th. I don't know.
Oh, okay. So first 8 weeks of next semester?
Yes.
January 27th, that's my birthday.
Really?
If that's the first day of class, you better bring me something. I will hold it against all of you. What was I talking about? Oh, better than C++. So here's the example. So you're having a party. You invite your best bud Mike over to the party. I was like, oh, sure, what time? In C++, they would let you do the equivalent of this. Party's at 8. Here's my house. Open the door at 8 p.m. Does that ever make sense in real life? Would you ever hand somebody your house? Why? It's heavy. Houses are heavy. You don't hand people houses. They'll get hurt. Right? Never makes sense to do that, does it? It never makes sense to hand somebody a house. And there are plenty of examples very similar to that where we can easily say it never makes sense to do that. Well, in C++ or C, it was programmer's choice. You could choose to hand somebody the house, or you can choose to hand them the address of the house. The address always makes more sense, right? Little tiny piece of paper, this is where I live. Okay? C++ empowered the programmer to make poor decisions. Now, not the end of the world in the big scheme of things, because advanced programmers sometimes could take advantage of some of those elements to pull off, let's call it, unique solutions to problems. Certain problems could benefit from the doors that were left open by C++ that allowed you to do stupid stuff like that. But for a beginning programmer perspective, and you guys are going to see, for those of you who haven't done programming, or those of you who say you've done programming but actually suck at it, you're going to see that you're going to have a whole bunch of errors at the beginning. Okay, they're just going to come flying at you like crazy. When you're a beginning programmer, it's everything you can do to get a program working, let alone doing it the most efficient way. C++ let you get away with murder when it came to efficiency. And it trained a lot of programmers to do the wrong stuff. But even worse than that, how many of you are familiar with the blue screen of death?
Yeah.
Anybody who runs Windows has seen the blue screen of death before. Anybody who runs iOS 7 on the new iPhone 5S has also seen the blue screen of death. Any of you have a 5S? The new iPhone?
No, it's too much money for it right now.
But you couldn't get the golden one.
I know. No. Are you friends with me on Facebook? Camped out for 15 hours. Second in line, and they didn't get any gold phones in. They got one gold phone in.
And somebody bought it.
Well, I wanted AT&T, he wanted Verizon. He bought the AT&T one to sell on eBay, sold it for $2,000, so he basically got a free phone. But in his defense, he was number one in line and didn't get the phone he wanted. Because he was for Verizon. He wanted the gold one for Verizon. But regardless, this is the 5S. This is their new phone. And it's got a new architecture on it. So it's related to what we were talking about. The chip that's inside of this is a 64-bit processor.
Holy man.
The chip that's inside of previous iPhones was a 32-bit processor. So very related, actually, to what we're talking about here. In fact, I mean, I'm not even joking. It is actually related. So for the last year, Apple has been working on this new operating system, iOS 7, and has been testing it on 32-bit processors. So they'd write it, they'd compile it to that architecture. This is a brand new classification of processor that's in this guy, a new 64-bit chip. So they had to port iOS 7 for the new chip. Well, they probably decided to put the 64-bit chip in here a couple months ago, maybe like a month and a half before the phone was released, let's say. So a piece of software they've been working on for a year to get ready for the 32-bit processors. They only had like a month to port it over to make it work for the 64-bit processor. So my wife still has an iPhone 5 that has a 32-bit processor in it. She's running iOS 7, no problems. I have the new one, the 5S, coolest, biggest, baddest, blah, blah, whatever, and it's a nightmare. My phone reboots 10 times a day. There's like stupid little bugs, like things that don't even make sense. You know, so like I'll voice dictate something. So let's say, you know, how many of you have an iPhone of some type that you do voice dictation on? Some of you do? Okay, so I might be, you know, instead of typing an email, you know, dictating an email. And sometimes, especially here on campus where you have crappy Wi-Fi, it'll sit there and spin at the end and not actually translate it. Fine, that happens. So I might sit there and wait 10 seconds. Didn't happen. I hit the backspace button to, you know, to tell it to stop trying. Then I maybe turn Wi-Fi off to use my cellular signal. Then I go and voice dictate it again. But maybe I reword it a little bit or make it short or whatever. When I hit stop, what does it do? It gives me my old message, the one I originally hit send. 100% of the time on the 5S. 5 works fine. No problem. This morning, This is the fourth or fifth time this has happened. I had hit snooze on my alarm a couple different times. So I don't remember the exact order that things have to happen. But eventually I turned my alarm off on my phone. But the phone disagreed. The alarm must be on. So I uploaded a screenshot from my phone on Facebook this morning. If you're not friends with me on Facebook, you should become friends with me on Facebook. I write a lot of funny stuff on there. So I uploaded this photo that showed that my alarm was clearly off. Yet the alarm icon was still at the top. So one might ask, well, is it just for show? No, it will still go off again. But then it would be even more interesting this time around because I was in the process of snoozing as opposed to waking up before the alarm originally went off and trying to turn it off. So the real question is, was the alarm going to still go off based on my snooze timer, or was I already ready for tomorrow morning? It was a snooze timer is what we found out. It also survived a reboot. I started the phone back up. Yep, icon was still up there. Like, did they even test this crap? Makes me sick. I'm willing to pay a premium for Apple stuff as long as it works. But don't do what the rest of the people do. Tell you what, Steve Jobs dies and everything goes to hell.
So, is that what you were cutting off this whole time in class?
Do what
For
now?
the first 2 hours? When your phone kept vibrating? Was that the alarm?
Oh, no, those are just text messages.
Oh.
No, the way to turn the alarm off in that situation is you go into the alarm, you turn it back on, and then you turn it off. Reinforcing that you actually want it off. Then it will go off.
That's,
Yeah, it's stupid. I get it.
yeah.
So anyways, C++ lets you get away with a lot of things. And the reason I brought up the blue screen of death question is blue screens of death happen under lots of different circumstances. One of them is things with corrupt memory. Since C++ gave a programmer free reign of memory, that's great if you know what you're doing. But if you're a beginning programmer, you're just going to overwrite memory when you don't know you're overwriting memory. So you could be in the middle of writing your program, trying to learn, and your machine keeps crashing because of your bad code. Well, how pissed off would you be if you're in the middle of doing your homework, and every 5 minutes when you write bad code, which, by the way, when you're starting programming, all your code is bad code for at least a month. It's hard to break into programming. And it's intimidating. And the error messages just keep coming by. Like, how do I even read this? Most of us don't even read it. What do? We just jump and start trying to change stuff until it works. Programming becomes trial by error. You know, hence the crap we have from VB programmers. It's true, right? Some of the crap you've looked at?
Yeah, I've looked at a lot of crap and fixed a lot of crap too.
All right, so in any case, Java fixed a bunch of this stuff. What Java did is they went in and they said, we really, really like C++. There are a zillion people out there who already know C++. We don't want to alienate those people, so we want to keep that syntax. We want to keep the C++ syntax. Okay, if I were to show you this tree here, more pictures, like pictures. We have C. Off of C came C++. And Objective-C. See? Apple, Microsoft. They didn't even like each other back then. These guys are fighting with each other at hardware level. For those of you who are Mac users, you could boot off a FireWire drive, but not a USB drive. If you're a Windows user, you could boot off a USB drive, but not a FireWire drive. Just petty things. All right, so the parent there is C. Off of C came, we decided, hey, object-oriented programming is cool, so we need object-oriented languages. So Microsoft pushed for C++. Apple said, well, we're not going to do what Microsoft's doing, so we're going to do Objective-C. From C++, came Java. And later C#. Notice I shifted it down just a little bit off Java. And for Objective-C, wait for it, Objective-C 2.0, Apple and their naming conventions. They're so stylish with everything else. Okay. Everything else. But at the end of the day, think about their operating system, stuff like that. OS 6, OS 7, OS 8, OS 9, OS X. Then they just started naming cats, right? After it. At least that got a little interesting. For iPhone, it's iOS 1, iOS 2, iOS 3, iOS 4, iOS 8. At least they can come up with some sort of animal, Android's doing that, right? Android, you got ice cream cone and sandwich and jelly bean, exactly. You got all sorts of fun names. Apple's supposed to be the cool one. So in any case, Objective-C 2.0. So this is kind of our hierarchical tree for these guys. So back to advantages of Java. It was better than C++. We took all this crap that was in C++ that wasn't bad for an advanced programmer, but was a problem for a beginning programmer. And even advanced programmers would benefit from not accidentally doing something that makes no sense. I mean, C++, you didn't just have to be dumb in order to accidentally hand somebody the house. A little tiny syntax change, and you were handing them the house rather than handing them the address to the house. The only difference was an asterisk. So, a very easy mistake for even an advanced programmer to make. Java fixed all that by just saying, look, you're always handing them an address. Deal. That's what Java did. In fact, something I'll say again, but I'll say it right now. If you look at a lot of the different Java textbooks, almost all of them, which is why I don't use a textbook, they're all liars. Almost all of them mention that pointers don't exist in Java. We're going to talk about pointers. Pointers are a primitive type variable for holding memory addresses. They say they don't exist in Java. The reality is Java only supports pointers. So it doesn't have a special syntax for it. It's more accurate to say pointers only exist in Java. Yet the books say they don't exist in Java, which is just stupid. That'll make sense when I show you some examples, but another stupid thing is why we don't have a textbook. So you can make your donation after class. All right, so other advantages of Java. I think those are the two main ones. All right, so enter C#. This is from Microsoft. Now let's look at how this guy works. Done. It's the same diagram I used for Java. I just changed all the JVMs to .NET.
That's exactly what the Microsoft did.
Mm-hmm.
Copy Java.
So first they just stole the syntax straight up. And then they say, you know what? If you're not going to let us have the syntax, we're at least going to still be platform independent. So C# was what? C# was C++ like syntax / Java like syntax. So they were both based off of that same tree structure. So back to, where was I at here? Where's my picture? Oh, here it is. So notice Java, C#, they're both derivatives of C++, which is a derivative of C. So a lot of the syntax is the same anyways. All right. So that was an advantage of C#. C# was platform independent. Which is great, right? But, now let me show you where they differed. Go back to this diagram. We already know how the other crap worked, right? So we can get rid of that. So let's look at C# in a little bit more detail. So in C#, we'd write a program. We would then compile that program down to Microsoft Intermediate Language, missile code. Okay, so this movement was a compile move. To go from those two steps required compilation. Then we send it into .NET. But .NET used a series of just-in-time compilers. So it's actually compiled twice. Hold on, I've actually made a mistake here. This is low-level language, assembly language. Then we had our missile code. So we compiled our program down to a low-level language. Then we fed it into a just-in-time compiler. I actually got to move the .NET over too. We fed it into a just-in-time compiler, which converted it into Microsoft Intermediate Language. And then we fed it into .NET, which is like the Java virtual machine, and that ran the app. Okay? The important difference here is after that second compilation, we're dealing with native code. So only the first time that you ran the program would there be that extra time of compiling a second time. After that, you'd have a native program that ran natively on that computer, as if it was compiled directly for the processor. So it worked very similar to how Java worked. But instead of writing your game once, compiling it to Java bytecode, and then running it on the Java virtual machine each time you wanted to run it, Java virtual machine kind of being like an interpreter, like me talking to him through you. Instead of it working that way, for .NET, for C#, the way it worked is I wrote down my English. You translated it into something else. Okay. But only once. He's the computer. You give it to him, and now whenever he wants to run that program, he already has a translated version of it. Instead of, with Java, it would be, I write it down, give it to you, you compile it, then you speak it to him, and then the next time we run that program, we do the exact same thing again. So I always use the interpreter every single time I run that program with Java. With .NET, I only use the interpreter the very first time, where you take all my code and you turn it into something he can understand forever. Does that make sense? So at that point, we get all of our performance back because now all the code that you run is native. So only the very first time we run that program is there a little bit of a delay for us to do that translation between English and Arabic, between a low-level language, some kind of assembly language, and Microsoft Intermediate language. Make sense?
And that's only on different platforms.
Well, again, remember that C# is, of course, platform independent.
Right.
And that's how it works. So which is better? C# sounds better, right?
Mm-hmm.
Oh, so you fell for my trap. Fell into a trap. Watch this. So C# is platform independent on any platform that supports the .NET component architecture.
That will be a catch.
So to reword this, C#, you could write your programs and they are platform independent as long as your platform is Windows. Because Microsoft did not create the .NET component architecture, the .NET stack for Mac. It's only for PC, it's only for Windows. So is C# platform independent? Absolutely. The whole .NET architect, the whole .NET language suite is platform independent as long as you're running Windows. Could Microsoft port it over to Mac? Sure. Why don't they? There's no benefit in it for them. Right now, if people write C# programs, they have to use Windows. First of all, they're writing software for Windows, right? So they're supporting Microsoft's platform. And they're also Windows users themselves. The second you allow people to start writing software using your product for somebody else's platform, you give up market share, don't you? And where's Microsoft's motivation? They have 94% of the market. Well, that's probably being conservative. I mean, they have a huge, huge percent of the market. They have no motivation to go and give that extra little 3 or 4% guy a bone. So it doesn't make any sense. So that's the funny thing with C# is C# is platform independent as long as you're running Windows. As long as you're running a platform that supports the .NET component architecture. So we go back to the Java side of things here. Sun Microsystems wrote the Java virtual machine for the PC. They wrote the Java virtual machine for the Mac. They wrote the Java virtual machine for Linux, so on and so forth. Microsoft did the same exact thing. They just chose to only write the .NET component architecture, only write the Microsoft virtual machine for Windows. Does that make sense? They stopped short of what Sun Microsystems did. So C# is actually a pretty cool thing in that it has all of the benefits of Java on the surface. Certainly it has the language benefits. Certainly it has the better than C++ thing where you know, in C# you cannot pass a house. You can only pass an address. So it has all those advantages from a programming perspective. It has the platform independence concept without giving up the performance, which is cool in and of itself. In fact, Java actually learned from this. So Java software today is actually a little quicker than it used to be because what they did is they inserted some just-in-time compilers in here to speed up certain aspects of a program. I mean, you're not getting native code. You're not to that point, but certain aspects are quicker. All right, so that's the difference between C# and Java. So kind of let me talk about the last thing here that kind of prepares you for your homework, and I'll have to put the homework up later tonight when Angel's back up, but you'll have 2 assignments, you'll have a week to work on it. One will be a simple programming assignment this first time. The second one will be a paper, you know, a 15 to 20 page paper. More than likely a 3 to 5 page paper. But if I don't get that birthday present the first class of the next one.
Hey, I have to double check the dates. Don't quote.
Well, even if it's around my birthday, that counts.
I know I need to double check to see
Maybe
if
I'll
it's
be
first
absent.
section or second.
Oh, you got to keep in mind though, I don't eat carbs, so you can't bring a cake. No gluten, no carbs. Bring bacon.
Bacon is awesome.
I love bacon. It's my favorite vegetable. So good. Name a better vegetable than bacon.
There is no.
No, there's no better vegetable than bacon. Oh, it's just so good. All right. ID. This is an integrated development environment. What is it really? A glorified text editor for writing programs. That's what it is. To give you a quick example here,
You said for writing.
for writing programs. The tool we're going to use in here is a tool called Eclipse. You use Visual Studio for writing your Visual Basic stuff. Eclipse is Visual Studio for Java.
Gotcha.
Okay?
I have to use it anyways for AI.
So you're going to be using Eclipse in here. And just to kind of give you an example of how this guy works. What you'll be doing for your first program for your homework.
Hello world.
What's up?
Gonna be hello world.
Yeah, but learning to use Eclipse is the thing. You'll create a brand new project, and there's a tutorial that you'll go through to do this, and then you'll write a tutorial to do this too. It's gonna be awesome. So anyways, ultimately, this is a text editor. This looks just like Notepad, right? But it does some stuff that makes your life a little easier. For instance, if I'm writing the main method, public static void main string array args, and then I put my opening curly brace, it puts the closing curly brace on there. You know, things that make programming life a little easier. Glorified text editor. All right, same thing. I go and write my code to print something out. And then come up here, hit the play button. Hello world. Now what's the alternative? Well, let's take a look. The old way. So let me do this on my desktop first. So I'm going to do vi blah.java. All right, so there's my Java program. But I wrote it out in a text editor called VI. I did the indenting myself to make it look pretty. I had to close all the curly braces. Now I'll write it. Now I don't have a play button. First of all, I got to compile it. So I'm going to call my Java compiler, javec, blah.java. And you'll see it now created a brand new file here called blah.class. That's my Java bytecode. Now to run my program, Java blah, and there's my hello world. That's what the play button did for me. I hit the play button, it compiled it, it ran it. I didn't have to do all that typing and crap like that. But appreciate the fact that you don't have to do all the typing and crap like that. Okay, because this was the way that used to work.
So where do we find Eclipse?
I'm going to show you.
Gotcha.
All right. So, and I'll put this up on Angel as kind of a formal assignment. You'll read it. But what you're going to do is you're going to go to a website, www.eclipse.org. It's going to take you to a page like this. You're going to click on Downloads. And it's going to detect what kind of computer you're on, whether you're on a Mac or a PC or a Linux machine. Okay? One of the reasons we tend to use Java as a teaching language rather than C# is for C#, you have to be on Windows to use the compiler. That's a 97% truth. There's actually a tool called Mono that lets you do it cross-platform, but it's not equivalent. You have to be on Windows for C#. This one, notice it already detected I'm on Mac OS. For you, it'll detect you're on Windows or on Linux or whatever you're using. The one you want is Eclipse IDE for Java developers. All the other ones will have extra crap in it that you don't need. Okay? Doesn't matter if you get the 32 or 64-bit one. They'll both work fine for you. So download that. Install it. There's actually no real installation on Mac or Windows. There is it just gives you a folder with an icon to double click on. Okay? But for Windows, you will have to install the Java virtual machine. Java virtual machine, you'll get from java.sun.com. You'll over here under new downloads, Java SE7 update 45. At some point they just need to call it Java SE8. It seems like. So click on that. Go through the process of downloading the Java SDK, not the JRE, the SDK. JRE is the Java runtime environment. The SDK is the software development kit. Software development kit lets you compile and run. Okay, more than likely you will have to download that for a PC. Okay, you very likely already have a Java runtime environment on your PC if you have the little Java logo somewhere on there for running Java apps inside of web pages, but likely you do not have the SDK. Macs come with the SDK. So if you have a Mac, you won't have to do this part, but a PC, you will have to download the SDK and tell Eclipse to look at it.
So,
For the Windows, you cannot download this JDK?
For what? Windows? Yeah, Windows. You would get the Java development kit. This guy.
okay.
Mac, you won't have to,
So
because the Macintosh already has it.
we get the Java.
Java development kit.
And then which ones out of the SDKs for Windows?
Well, hold
You
on.
were just pointing to the side.
Oh, I was just moving the mouse around.
Oh, okay.
Yeah, you want the Java development kit.
Gotcha.
This guy. Once you have that and you have Eclipse, you'll tell Eclipse where your Java development kit was downloaded, and then it'll work.
Okay.
Okay? And I'll point you to a couple of tutorials for getting started with Eclipse on the Eclipse website that tell you if you're on a Mac, do this. If you're on a PC, do this. Okay? But ultimately, what we're going to be using in here is an integrated development environment, and that integrated development environment is going to let us write our programs and test them easily. All right? So, go ahead.
Oh, I'll ask you after.
So, like I said, the homework assignment might not be up till tomorrow morning. Depends on how friendly Angel is being. It looks like the network's actually working a little bit better here tonight. But in any case, your assignment will be 2 parts. Actually, 2.5 parts in this case. I will be having you go through the process of getting Eclipse downloaded and installed and writing a hello world program, like kind of your simple first program. On one hand, that proves to me that you have a development environment you can code in. I will also then have you write a tutorial for teaching other people how to get it up and running, okay? Because we are IT majors. So part of what we're going to be doing is we're going to be instructing other people how to use technology. So you need to be able to take what you learned how to do and explain it to people who might be less technical than you are. Okay? Then there'll be a paper component that will be related but unrelated to that exercise. Okay? And make sure you get it submitted before class begins next week. So you have a week to work on it. Just make sure you have it turned in before 6 p.m. a week from today. Don't come in and say, oh, I left my disc at home and my dog crapped on it. Can I turn it in tomorrow? All right, got it? Questions, comments, concerns, bribes? All right, I'll see everybody